Hello everyone, good afternoon. My name is Satryo Naufal and my NRP is 5019201106 and I came from Marine Engineering Department. So today I would like to solve one case of physics. Enjoy the work done by myself. Okay, so the question we are going to answer is about the Gauss law. So, there's a conductor ball with a radius of 1.5 centimeters and its lot is equal to Q equal to minus 20 nanocoulomb. And inside the conductor ball, there's also an isolator ball with a radius of B equals to 2 centimeters and there's also an outside radius which is C equal to 3 centimeters and it has lot of Q equal to plus 30 nanocoulomb. So the question is, with the Gauss law, we have to find the electrical field that's equal to zero. Okay, so before begin the calculation, we have to know first that the inside one with the big key, it's called the conductor, and the one that is outside with there's a little key sign, it's called the isolator. After we know both of the where's the conductor and where's the isolator, uh, we will continue to using the Gauss law. So we're going to write the Gauss law equation, which is equal to the integral of E times dA equal to Q divided by epsilon 0. We have to put this equation equal to 0. Why? Because the question is asked us to find the electrical field, the magnetic field with the zero equal to 0. But the problem is we cannot equal the epsilon 0 equal to 0. So we can put the Q equals to 0. We have to put the key total equation, which is the key conductor plus the key isolator. And also this key total equation we have to put equal to 0 because we're going to find the electrical field which is equal to 0. From the equation key total, we know that the key isolator is equal to the minus of the key conductor. So we know that the equation of the key isolator itself, it is equal to the integral of the rho times d and times v, or we can write it as the 4 times b times r squared times d and times r. So the rho itself, it comes from the total of the key isolator and divided by the total of the volume of the isolator. After that, we can replace the rho on the key isolator equation into the total of the key isolator divided by the total of the volume of the isolator. After that, the total of the V isolator, it's coming from the 4 per 3 times V times C cubic minus B cubic. After that, we can replace the total of the V isolator in the key isolator equation into the key isolator, the total of the key isolator plus divided by the 4 per 3p times c cubic minus b cubic times 4 per 3p times r0 cubic minus b cubic. After that, we can eliminate the 4 per 3p on both sides. So the equation, it's going to become the total of the key isolator per divided by the c cubic minus b cubic times the rho cubic minus b cubic. So basically we know this is the key isolator equation, and based on the top, the key isolator it's equal to minus key conductor. After that, we're going to find the rho cubic. So we're going to put the rho cubic in the front on the left side, and the equation is going to become minus c cubic minus b cubic times key conductor divided by the key isolator plus b cubic. So we're going to put the value of the every variable in this equation. The c in the question is known as 3. So if 3 cubic it's equal to 27. After that there is b, which is the value is 2. So it became the 2 cubic, it's equal to 8. Don't forget to change the centimeters become the meter. So it becomes 10 power by minus 6. After that, the key conductor itself is minus 20. So it becomes the minus 2 divided by the key isolator, which is plus 30, becomes 3. After that, we're going to plus the b, which is equal to 8 times minus 10 minus 10 power minus 6. After doing the calculation, the result that I get is the R0, it is equal to 2.98 centimeter. So that is all from me. Thank you. I just realized that I forgot to put the minus sign on the equation. I'm sorry for the mistake. So the result can be written as 2.98 centimeters or 2.98 times 10 power by minus 2. Thank you. Sorry for the mistake.